Welcome to tonight's first video for summer geometry, Unit 1, Tools of Geometry. We're going to talk about some of the terms in geometry that you're going to use from here on out and then there's also talking about points, lines, and planes. But the first thing we're going to do is do a little algebra review. So the first problem here asks you what is the value of x squared plus 3xz if x equals 3, y equals 6, and z equals 4? What I'd like you to do actually is to do these 6 problems on your own, and then I'll show you the answers. Looking at the answers here, we have the first one where you substitute in the values for x, y, and z, and you get 45. The second one you distribute in, so you get 2x minus 14 equals 5x plus 4, and then you move the x's to one side and the numbers to the other, and you get 3x equals negative 18. Negative 18 divided by 3 is negative 6. B is the solution to 3x plus 4y equals 14. The other ones do not work when you put them in. For number 4, remember this is slope-intercept form, so the y-intercept is 2, and then you go up 3 to the right 1 with the slope, and you can also go down 3 into the left 1 to get your line. Number 5, this is the difference of two squares, so 3x plus 5y, 3x minus 5y. And for number 6, a quadratic equation has to have 2 as the highest variable for x, so therefore that's why D is your answer. So now, getting into geometry, there are 3 terms right away that we're going to talk about. And the first one is a point. Now these 3 terms are what are called the 3 undefined terms of geometry, meaning there's no end to them. They just go on forever and ever. The first one is a point. A point doesn't have any shape or size. You just label a point by a capital letter. So here this is point A, but you can't measure a point. The point is just a marker for that location. A line is made up of points. You need 2 points to draw a line. It has no thickness or width, like there's really no measurement to the line. And lines go infinitely in both directions. And the way you name a line is you can name it with a cursive letter here, like line M. You can name it with either of the 2 lines, so like PQ or QP. And notice with a line, the symbol is always with the 2 arrows. So you could either say PQ or line QP. Either way. A plane is a flat surface made up of points. You need at least 3 points that are not on the same line to make up a plane. And then the way you name a plane is you could do a capital letter, like here it would be plane K, or you could write it in any order of the 3 points. So here plane BCD or plane CBD. Any three of those letters will give you the plane. Some things to think about that are planes, like the desktop is a plane or a wall is a plane. So there's plenty of planes in our real world. All right, so next we're going to look at some diagrams and see what planes and stuff we can look at to see and answer the questions. So for example here, it says use the figure to name a line containing point K. So here, there's a couple ways that you could do this. You could say it is line A, because the cursive letter A is the line. Or you could have said line JK, line KJ, or line JL, or you could have reversed that too and said line LK or KL. So those are just a few of the ways that you could have named a line containing point K. It also says use the figure to name a plane containing point L. Well, here it's plane B. Or if you wanted to, you could have also said plane KLM. That's another way. Or you could have said plane JK or JLM. So in this one, use the figure to name a plane containing point Z. Well, the cursive letter here is P, so we could have said plane P. Or another way, we could have used a combination of these three letters. So like plane X, Y, Z. All right, the next thing we have to talk about is what it means for points to be on the same line, and that's what we call collinear points. So collinear points are points all on one line. They're on the same line. So here when it says draw and label a figure for the following situation, line QR, Q is -2, 4, so -2 and up 4, so there's Q, point Q. And then R is 4, -4, so there's R. And it says place a point T so that T is collinear with these points. So if you look and you were to draw a line through from Q to R, you notice that T could be any point between there. So we'll call that point T. And T is collinear with points Q and R because it's on the same line. So then next it says draw and label a figure for the following situations. Plane R contains A, B, and D, E, which intersect at point P. So here's plane R. We'll draw a flat surface. We'll call it plane R. Here's line AB. Here's line DE. However, we're going to place a point C on plane R so it's not collinear with A and B. So we'll make this D, we'll make this E, and then here's P. Right, because P is the intersection point. And then point C, we could just place out in space here because it's not collinear with A, because not collinear means not on the same line. All right, so then number 11, it says choose the best diagram for the given relationship, and it says plane D contains line A, line M, and line T, with all three lines intersecting at point Z. Also, point F is on plane D and not collinear with any of the three lines. So if we look here, part A, plane D contains line A, line M, and line T. Well, line A is not in plane D here, so we can eliminate A. For B, notice the three lines are on plane D. They intersect at point Z, but however, point F is on the line there, so F is not collinear. C, if you notice the three lines are on plane D, but F is the intersection, which is not what it was supposed to be. And so here, this is the only one with the three lines that intersect at point Z, and also F is not on any of the three lines. So D is your final answer. So if we talk about coplanar points like collinear, except now we're talking about planes, they're points that are on the same plane. How many planes are there in the figure? There's just one. There's plane S. Are there more planes that aren't shown? Yes, because you can create more planes with just three non-collinear points. Are points A, B, and C and D coplanar? And the answer is no. They are not coplanar, because notice A, B, C, B and C are on plane S, but A and D are not on plane S, so therefore they are not coplanar. So look at the next diagram. Are X, O, and R coplanar? And the answer is yes, because notice they're on the same line, which means they're on the same plane. Name 3 points that are collinear. Well, you could say B, R, and N. They are collinear. You could also say X, O, and R. They are collinear. So those are the two options that you have for 3 collinear points. At what point do BN and XO intersect? BN and XO intersect at point R. So here's another diagram. Name 3 collinear points. You could say A, T, and B. Those are collinear. What is another name for line AB? Well, you could say it's line TB. You could say it's line BT. You could say it's line TA. Those are 3 options that you have. Name a line in plane Z. Well, they're in plane Z here, and Z is the reddish line. Notice line L. Name the intersection of planes Z and W. Well, the intersection of planes Z and W is line BA. Or you could call it line AT or line BT. Either way, it's the same line. So how many lines are shown in plane Z? Well, in plane Z, right here, there are 1 and 2 lines. How many lines are there really? Well, really, you could have infinitely many lines. All right, so true or false? The intersection of a line and a plane is a point. That is false. It's false because you could have the intersection be a point, but the intersection of a line and a plane could be a line as well. So it just depends on the diagram. There's only one plane perpendicular to a given plane. That is false. you can have multiple planes be perpendicular to a given plane. And perpendicular, as we'll talk about later, means 90 degrees or right angle. Collinear points are coplanar. That is true because any points that are on the same line have to be on the same plane. And a plane contains an infinite number of points. That is also true. Even though you only need 3 points to make up a plane can be consisted of infinite number of points. All right, so that concludes our video for part 1 of the notes. If you have any questions, please feel free to ask during class or send an email. All right, see you for the next video.